Welcome once again, everybody, to Deep Web3 Secrets. We have a very special episode today. We are interviewing Blocktrades about HAF, the HIVE Application Framework, and we would like to demystify HAF. How are you doing, Blocktrades?
Doing good.
Fantastic. Now, you have developed this incredible solution to quickly getting specific data out of the Hive blockchain. I think we all believe that Hive is an incredible database, and you are putting in a layer that makes it true. You know, we're moving from Hive can do to Hive is doing. And so if you could just explain HAF to me like I was 5 years old or like I was a kinder, go ahead.
Okay, so basically, half came out of when we were first starting Hive. One of the things we noticed was that a lot of if you wanted to make changes to the API calls are how other applications get data from Hive. It originally you actually had to change Hive D itself, which was the central core code, and that's all written in C++, and it's kind of a pain to work with for most people. So we wanted to get the data out of there into a database, which is where the data is stored in a form that more people can easily access it and get the data they want quicker, that kind of thing. So one of the problems with having it in Hive D, in fact, was that when everybody was making calls to Hive D directly, that puts more stress on Hive D because every time somebody was getting data from that internal database in Hive D couldn't actually write to its database. So this could potentially, if a lot of calls were going to Hive D, the network could just like sort of slow down. So we weren't the first ones to spot this. The Steam guys kind of knew this too. So one of the things they did was create this application called HIVEmind. And HIVEmind was basically a database where they took some of the data out of Hive D and put it into a separate database, so that then all the calls that are getting data would be getting data from the database rather than directly from Hive D itself. But the problem still that existed was the data in HIVEmind was only in a certain format, and they give you a certain set of API calls that you could use to get the data. So you had to get the data the way they wanted to give it to you, or the way they thought you needed it, and that worked fine as long as that's what you wanted. But if you wanted the data in a different format, you would still have to do a lot of work. In particular, another problem with HIVEmind is it just didn't have all the data. So it only had the data that they thought were needed by like social media applications. So HIVEmind was very much tuned the data to give you the data you need to show them like hive.blog or peakd or something like that. But if you wanted more general data, for instance, if you wanted to understand like custom JSON operations, custom JSON operations are like special operations that anyone can create for their own application. So custom JSON operations, for instance, are used by like Splinterlands as an example. Basically, almost all the games use custom JSON operations, and that data just wasn't in HIVEmind at all. So the way those applications had to get the data, they had to go back and actually ask Hive D directly for the blocks. And they would have to get the whole block, which that would include data that they really weren't interested in. And it's also put a much more strain on Hive D. So one of the ideas behind HAF is basically to get those blocks, get all that data that's in the blockchain out of it. Hive D just basically pushes it into the database as fast as it can. And then everybody else that wants to get the data gets the data from the HAF database instead. Now, this isn't a completely new idea. A lot of applications have done this themselves. They would get the blocks from Hive D, and then they would actually use their own database to get the data afterwards. But for one thing, they were getting the blocks. They still had to get the whole blocks from Hive D, and they weren't doing it as efficiently as it could be done because the API just didn't support getting it as efficiently as possible. So with HAF, we actually allow Hive D to directly inject the data into the database. It's not the other way around. It's not the database asking for the data. It's Hive D says, oh, I got a new block, put it in the database. So it gets there as fast as possible. And another thing that comes up that people could have a lot of problems with is when they were getting blocks from Hive D, blocks could, the database could, the Hive network could fork at times, which means a block gets created, and then before it gets accepted by enough block producers, another block comes along and replaces it. And so there's a point in time which blocks become what we call irreversible, which means that you could trust them now to be used. They won't change. But when a block first gets created, that's not true. And people were often asking for these blocks, and then occasionally they would ask for a block, put it in their database, and then that block would get forked out. So it was no longer valid. And this could kind of mess up an application that was relying on the block's data, because now the data is slightly different in the block that replaces it. So we wanted to solve that problem of dealing with forks. That was the other big design goal for HAF at the very beginning. Does this all make sense so far?
Great. Let me step in here. Great. And so much good stuff. I'm just going to back us up before we continue. Now, first of all, I find this fascinating about HIVEmind. It didn't have all the data. So the people that created it put in the data that they thought were important at that time. We're living in a different time, and we believe that Hive can do many more things than just be a social media app. So is it the case that HIVEmind would be a type of HAF app for social media apps?
Yeah, it is now. So it originally it wasn't. It was like a standalone database. It had its own standalone database, but we re-architected HIVEmind so that in fact it is a HAF application nowadays.
Perfect. And maybe I just tap in here. What is an application? You know, when I started reading the documents with my partner, the Crazy GM, we thought this is such a great idea. We had actually spent a lot of time bespoke building exactly what you're talking about, our own database with our own precautions and our own ideas about what was important to us. And we started reading HAF and we said, oh my gosh, we can dump all that, save so much space. We can run a HAF node and we can put the plugins in that we want, the apps that we want to use, and we got them. Okay, so, but when I started to explain that to other people, I felt like they were thinking that they were going to download it on their phone. So if you could just unpack a little bit, that what is a HAF app in the sense of like
that's a great question.
Application.
Okay, so it's a HAF app isn't what normally people think of as an app to some extent, because when somebody thinks of an app, they usually think of like a web application, like Hive.blog or any of these other apps. So you go to a website and you interact with it. So that's like that's what we could call that a user interface app. It's an app that users actually directly work with. But those front-facing, those web-based apps behind the scenes have to make API calls to get data from another source, and that's a database. So what a HAF app is actually it's an API it's a server that supports a set of API calls. So any given app needs to get certain data, and it gets those data by making API calls. And so the idea behind HAF apps is you can make a custom set of API calls that directly match the needs of your application and maybe a couple other applications that have very similar needs. And you create a HAF app to do that. So the HAF apps aren't a user interface. You don't see anything on your screen. They're a back-end thing that allows you to get data in the way you want it. That's what a HAF app actually is.
Okay, fantastic. And then maybe we can unpack these as we go, but do you just want to run down what sort of apps are being worked on already? I know your team, you have a big team, and they're very productive doing several of these apps already for what now you think is the most important data use cases. Just walk us through quick and we can see which ones maybe we want to unpack a little more.
Sure. So the first one one of the first ones we created was one called BalanceTracker. And it was sort of actually created to be like an example app so other people could see how to create HAF apps. So we didn't want to make it too complicated, but over time it has gained some functionality as we keep finding things it's useful for, because it turned out to be useful for more than just an example in the end. But so BalanceTracker would basically, the way a HAF app works is each block is first added into the HAF database. And then when you start a HAF app, it can start walking through all the blocks that are stored in the database and processing those blocks and getting the data that it wants and putting it in its own local tables. So basically a HAF app has two pieces to it. One, it reads the data from the central storage of the HAF itself and reorganizes the data into tables that meet the needs of its own API calls. And the second, we call that an indexer, because basically it's taking data in one form and re-indexing it into a form that's more appropriate for the application, for the HAF application. And the second part of the HAF application is a web server that basically makes queries to those tables And this web server basically supports different. This is where you define your API calls. So this is where you define the set of calls that a UI application, like a Hive blog or whatever, will make, what kind of calls it'll make to then read that data from its local tables. So the balance tracker, when the whole point of this app was to allow you to see, like, historically how your balances had changed in your account. And by balances, I'm talking about your Hive and your HBD. So the API, if you look at the API calls for balance tracker, you'll see one allows you to say fetch how your balances of Hive have changed per block over the last 30 days, for instance. And then you could get that raw data, then you could graph it in your graphical application. So that was balance tracker. Another one we created was to deal with account history, more generally account history. So if you ever go to your wallet on most of your applications, you'll see like all your transactions, like you see every time you did a transfer from one person to another, or when somebody sends you money through Hive. And that's done through, that data is stored, those API calls are managed by HAfAH, which stands for HAF account history. So it's just a way you can see account history. So they're similar, you think, because they're both dealing with money, both the balance tracker and HAfAH, but one is giving you like balances, how they change over time, and the other is just showing you the individual transactions that are affecting those balances. So they are two different sets of API calls. Of course, HIVEmind itself, that was a very important app for us to change into to make it a HAF app. And so the big thing we did there was, well, one of the first things we did there was the data used to have to come directly. The HIVEmind would used to actually directly ask HIVE, the main node, to get the data. And now it gets it from the HAF database instead. And that allowed us to fix actually one kind of problem with HIVEmind, was that HIVEmind, if it got blocks right away, remember I talked about this problem where if you get the block right away, the block might get thrown away later, and then you have bad data in your database. So the way HIVEmind solved this originally was kind of, let's say, not perfect. It just delayed 2 blocks. So it said, I'm going to wait, stay 2 blocks behind the head block and only show the data 2 blocks later. Now, this is not perfect for a couple reasons. First of all, you're delaying how long before you can show the impact of a new block, because you're saying, I'm going to wait 2 blocks to be sure this block is good. And the other problem is, with just waiting 2 blocks doesn't ensure that the block you got is good. So you could get a block, it could still get a block that had bad data in it, and that data would stay in that database forever.
Hold on, let me step on you here for a second. Now,
sure,
that
no
issue specifically was fixed in one of the more recent previous hard forks, right? So it's an incomplete solution, but the first thing you actually did was make it almost better, right? And now you're fixing it completely?
We actually did it the reverse way. We fixed it completely with HAF originally, and then later I saw a way to make the problem not so bad.
That's funny. That's funny. Okay. Yeah, go ahead and continue then. Sorry, I just wanted to make that clear.
Yeah, so let me explain how HAF makes it better first. So what HAF does is when it gets a block, it does get the blocks right away. The impacts in it changes the tables. But if it later, the HIVE tells it that block has been replaced, everything that's been done as a result of that block can basically get rolled back. So all the database changes that happened because of that block get reversed back to the state before, and then the new block gets applied and the new state gets changed. So the HAF design allows your application to basically reverse its state when a block is if a block gets thrown away by the blockchain. So that's kind of one of the magical things that HAF allows you to do. That's not easy to do something like that, because normally once you process the block, you basically made all these changes because of that block. And every single one of those changes in your database needs to be changed back to the state before that block was added.
Let me back out to the 5,000-foot view here for a second, in case there's any normies listening in or wannabe devs, because, one of our ideas on Hive is it should be easy to do stuff. We think that Hive is fast and free, and that's really good. And is it the case that we're already 3 seconds, 9 seconds, we're better than everybody else. Why do we care about these tiny little details?
So it's good question. It depends on what you're doing, of course. Some things you want to be really fast to have responses, and some things it's not so important. One of the things you could do in the past, if you didn't want to worry about this problem, is you could wait till a block becomes irreversible. And when we designed HAF, that could take a while. Literally, in theory, it could take hours in really bad conditions, but practically speaking, it would normally take somewhere around probably 8 or 9 blocks. I forget the exact number. So probably around 30 seconds or so. And you can see this if you watch some of the apps that are some of the second layer apps that like Deluxe. It's basically a smart contracting system. And if you watch it, when you do a transaction on it, you'll see that it waits about 30 or 40 seconds before it says your transaction is complete. You might have noticed this in like Hive Engine too. When you do a transaction there, you might see that it takes. So the reason those were taking so long is because those were having to wait till the block became irreversible. And so they had to do that kind of delaying.
Okay. So let me just nail this on that. You're telling me that all of our great second layer things that we've been playing with have just been sitting around waiting because of this issue specifically?
Well, I assume that's what most of them are doing it. So and it's funny because this issue is kind of addressed somewhat later after HAF, which is that we added something called one block irreversibility, which that allows blocks to become irreversible faster than they used to. It used to, we'd have to wait for, basically the way each block producer would say that a block was good is they would produce a block on top of it. So you had to wait for a bunch of blocks to get created for enough witnesses to say, okay, I'm okay with that block in the past. And then you could say, okay, this block is irreversible. But we made a change which said witnesses could immediately vote on a block rather than having to wait for their turn to build a new block based on it. So that means that in practice now, within several hundred milliseconds, that's about a fifth of a second, typically all the block producers have said that they like the new block and it becomes irreversible. So it's really quite quick nowadays, generally. It's assuming there's no network problems between the communications problems between the nodes.
Well, okay, so that brings me to the next question. All this stuff is all well and good under normal conditions, but talk to me about that one moment, that chaotic, incredible attack, money attack, anyways, however it could happen. Talk to me about critical moments in terms of like building things that should last forever, you know?
So the way that can happen where it takes longer is if the nodes have trouble communicating with each other. So a classic case of something like this would say you have a bunch of nodes on one side of an ocean and you have a bunch of the nodes on the other side of the ocean. And then the cable gets cut between those two sides, or there's just some kind of computer problem on the computers that are dealing with transmitting the data back and forth, right? All kinds of things that actually do happen in real life. And in that case, basically you don't have enough nodes necessarily to communicate with each other between the two sets in order to say make a block irreversible. We require 75% of the nodes to say that the block is good before we allow it to become irreversible. So in that kind of split condition, now you got blocks being generated on both sides of the ocean, and you don't know which blocks are going to finally become the ones that become irreversible in this scenario. And so that's the case. That is a failure case where you want to be able to take all the blocks that you process and say, okay, maybe I can make the changes temporarily and I can see what it's going to look like, but then at the end of the day, when the network gets connected back up, I need to go back to what turns out to be the final answer. And so HAF was built to handle that kind of case.
Wow. And I always go to, I live on a mountain, and my go-to is, if my volcano explodes, because it's an active volcano, it blew up in 85, then GM, he's in another continent. But cable cutting is particularly apt example. Okay, so let's go back. I got BalanceTracker, I got HAfAH, I got HIVEmind. What else is being worked on or is worked already in terms of apps?
So in terms of apps, we've got, HAfAH, HIVEmind, BalanceTracker, and then another one that we have is called BlockExplorer. And that's one of the newer ones. And that's new part of, so I should mention we're releasing a new version of everything recently. And we actually released the BlockExplorer already, but we didn't make it one of what we call the common stack. So the common stack is a bunch of apps that when there's several people out there that are running HAF API nodes. This is what we call API nodes. People are probably familiar with them from like API.deathwing, whatever, and API.hive.blog, et cetera, et cetera. So there's a bunch of these nodes out there, and they are all running HAF servers, and they're running the standard HAF stack. So by the standard HAF stack, I mean the standard apps that we basically put out and said, everybody should probably run these. And so those right now, the ones that are in standard as of now are HAfAH is one, HIVEmind is one, and BalanceTracker is one. And a new one we released, but we didn't make part of the standard stack last time, was the BlockExplorer one. And the reason we didn't make it part of the standard stack is it still wasn't as high performance as we wanted it to be. So we wanted to wait until it was heavily tested, that the API couldn't load down a server in any way, because we knew that some API calls you could make with the BlockExplorer API could be slow, and they could slow down the overall server's performance. So we waited, and so we're releasing that as part of the standard stack with the new release. We're releasing a new version of HAF this week or next week, and so now that'll be a new part of the standard stack at this point. So basically, when we first create a new app, we don't necessarily make it part of the standard stack until we've had time to really spend a lot of time with it.
Okay, good. But what does it do?
The BlockExplorer, it's pretty much just what its name sounds like. It's an API for anyone who is running a BlockExplorer. If you want to get data, the type of data that a BlockExplorer might want to use is the BlockExplorer app is designed to provide that kind of data. So we do generally whenever we make a HAF app, we usually do make like a reference user interface, just so people can, it allows us to test the API in reality, right? To be sure that it actually, the API matches the kind of data you want. And it also teaches us how to figure out what kind of new APIs we might want to add, API calls we might want to add to the API. So we do have a BlockExplorer user interface that uses that API, and that's a web app. And we developed that, and right now McFarhat's team, ActiveFit team, is managing the further development of that application.
Fantastic.
So you can see that app. There's various places where it's running. We run a couple copies of it, and he runs one too. So there's maybe some other people at this point too, because it's all open source. So the idea behind making BlockExplorer part of the standard app is now. So one of the reason I wanted to make that a standard app was I saw a long time ago that Hive has always had a pretty great BlockExplorer. Even from the very beginning, there was like HiveBlocks.com, and it's a really nice BlockExplorer. But the problem is one guy runs it, and whenever it went down, it could be kind of a headache. So I wanted to, since the BlockExplorer data is such important data, I wanted to kind of decentralize the availability of that data. And also I wanted to be something that's very quick. So that's why we designed the BlockExplorer API. And the idea is now all the API nodes out there, and there's probably like 20 or so, can all run the BlockExplorer app. And anybody can then also run the BlockExplorer user interface, so the web server. They can run their own web server. So you could even nowadays you can actually run your own copy of the BlockExplorer and just point it at one of the API nodes and get that data. You'll be able to get the data from whichever one you want. You can even go so far as, of course, run your own API server and have the data all local.
I want to tap in here because this is another thing. And obviously, like you said, you're building out these apps, which are back-end. How did I write it? Hold on a second. These are custom set of API calls against indexed data. And so it's very quick. But that is a different thing than what some people might call apps, which might be like a web app. And the right way to say that is a user interface. So, obviously, this is open source. I say obviously, but here we are demystifying it. How do you view the relationship between the user interface and the app in a world where most people relate the user interface to an app?
Yeah, that's a good question. So there's kind of two models for how you might want to develop a HAF app, right? This API server, your set of API calls. One is you could tailor them very, very specifically just to your own application. And, that often will make sense. And I think a lot of people will do that. They'll create an app that's just exactly they'll create an API that's just exactly for their application. The advantage to that is you can do things like you can like on a web app. Typically, you have different pages, right? You can go to this page or that page, etc. And whenever you go to a particular page, that app has to make some number of API calls to get all the data to show on that page. But when you make your own custom API call, you can conceivably do things like have one call that just gives you all the data you need in one single call. So that can be a very, very efficient way to get the data you need. So HAF allows you to do that. You can make such a custom API that you can have an app that just an API that just directly matches each page on your app, for instance. And maybe there's a couple calls if you have things you can do, like press a button on that page, etc. But on the other hand, you may want to make an API that you might have to make several calls to get all the data you want, but you've separated the data into very logical things that lots of other people might want to use. So you can make a broad-based API that's useful for more applications. So both HAF doesn't really say you have to do one or the other. It's kind of left open to you. In fact, what you made probably an app is going to often wind up doing a mix of that. So you're not going to necessarily create new API calls for data if there's already an API call out there that matches pretty much what you need. So you might use another. You can actually your web app can actually fetch data for multiple HAF apps, right? It doesn't need to just get all its data from one source. So it could be getting one set of data from account history. It could be getting another set of data from HIVEmind. In fact, that's all the apps. They work that way now. Most of the apps that we have that use the standard HAF API, the standard Hive API, are actually making calls behind the scenes to multiple HAF apps. They don't necessarily even know it because they just make all the calls to a central server, and that central server then dispatches the calls out to the appropriate backend API.
Fantastic. Okay, I think you did good. Congratulations. I've been working on how to say these things, some of these things too, for a little bit here. Now, you mentioned BalanceTracker, HAfAH, HIVEmind, BlockExplorer, and then they're open source. So talk to me a little bit about HiveSQL. We are funding another HAF app, and as I understand it, so it's not.
Actually, let me catch you there. There's actually two apps that can with similar names that you could get confused on. One is HiveSQL, and one is HAfSQL. And so HiveSQL is actually basically what we were talking about originally. This is Archange. He took the data from directly from HiveD and puts it into a database, and then he allows you to query that database. So that was HiveSQL, and it's still around. And then the problem with HiveSQL, from my point of view, is the code is not open source. So basically, there's one server for HiveSQL data out there, and if it goes down, you're kind of out of luck.
Or if he gets unfunded.
Yeah, exactly. So there's big problems. And so Matayari, and I'd always kind of been concerned about this, honestly, because I thought it was a bad idea to be building too many services we're starting to build on top of an API that's essentially proprietary. And Matayari suggested creating a SQL app, a new app that basically mimicked the functionality of HiveSQL, but on top of HAF. And I'd already kind of had the same idea, so I was very happy to hear him suggest it, and because our team just didn't have the bandwidth to work on that. So he put out a proposal to do that, and that's what HAfSQL is. It's essentially it's a functional clone of HiveSQL, but it's open source and it's built on top of HAF. So that gives it a couple advantages. A lot of the work was already done in terms of the data is already available inside HAF itself. It's now deployable to anybody who wants to deploy it because it's open source, and if they've got a HAF server, they've already got most of the work done. It's also super fast in terms of the speed it gets data. And so if there's a problem with any of these servers, it's not a big deal to get it back up nowadays. So that's what HAfSQL is. And HAfSQL is basically, it's not part of the standard stack yet, but it's pretty far along in terms of beta now.
Well, fantastic. I'm glad you stopped me there, actually, because my mind skipped right over that. And so, but let me just go back and hit the other half of the question. So this is open source stuff. And this is not the podcast to talk about open source philosophy, but I'd love to have you back on for that. And we can schedule that for some other time. But just talk to me through, you are a builder. Not everybody understands open source, but talk to me through, you're a builder, you're building stuff. this is maybe even your baby, and somebody comes along and says, I want to build on your baby. How and you did kind of say you felt very validated and you were happy about it, but talk me through how this works. Why were you happy? Don't you want all the credit? I mean, maybe just unpack that a little bit for us.
Well, I mean, I think there's something that was like I can't remember this exact saying, but the highest form of praise is emulation. but anyways, I'm absolutely happy for people to build on top of what we're building. In fact, most of the reason we built HAF was just for that purpose, is for other people to build on top of. Because one of the things that was very difficult originally was to make changes to Hive, especially when most of the changes had to be made in that C++ code core. If changes were made there, you had to understand some fairly complicated code, and it was easy to break things. So the whole point, the whole point of HAF, I want to say one whole point, but there's several points. But one of the main points of HAF was to make it more easy for other people to build stuff on Hive. That was kind of the driving force for it in a lot of ways. And so a lot of the, we just analyzed a lot of the problems that people would face when trying to work with Hive, and HAF was basically solving those problems. So yeah, I mean, the whole point of HAF is for people to create their own custom APIs. That's what it's designed for. HAF isn't an application itself. It's a framework for other people to build applications on top of.
Nailed it. Okay, great. Now, the next thing I got on my list here, data structures. As people who build things on top of all that complicated C++, we often use, and I think a lot of people out there are accustomed to using Mongo. Very flexible, and I mean, it marries well with custom JSON, flexible, but in terms of data structures, HAF is using PostgreSQL. And this is a super efficient database, but it's rigid and inflexible. So maybe just break down some trade-offs in terms of data structures and why you made the choices that you made.
Okay, so well, I'd probably have a different view of Postgres, but so Postgres, first, what Postgres is. Postgres is a SQL database. So the original SQL database was one by Oracle. It's very expensive proprietary database, but it's very, very powerful. It's probably most, it's in terms of I guess for sale databases, it's probably the biggest in the world. So SQL has been around forever, and it is, in my opinion, the dominant language for databases. And I think this just is not really opinion, but. So when we were looking at what databases to use, we figured SQL was the right thing to do, and we've been working with SQL forever. Blocktrades, our commercial company, basically used SQL as its backend. So there's several different possible SQL servers out there. Microsoft has one. Oracle has the most famous one, and there's like MySQL, it's a free one, and Postgres, which is also a free one. So of the ones that are out there, Postgres is like the free one that's also extremely high performance. So the guys at Postgres, they just do amazing work, in my opinion, in terms of performance and features too. They really offer a lot of features. So I actually really love Postgres. I think it's quite impressive database application. So it is a SQL server, and but there's tons of things you can put on top of it that actually allow it to interface very nicely with web apps. In fact, one of the ones that we kind of really push hard, we're using it for all our HAF apps, is an application called PostgREST, which is confusing because it's like Postgres and it's got the letter T on the end, but it's not Postgres. It's a separate thing. Essentially, what it is, it's a web server that you can run and hook up to your Postgres database, and it allows you to essentially make you can easily define like SQL queries as API calls, essentially. So you can actually, even if you want, you can even open up all your tables so that you can basically make REST API calls and fetch tabular data from your database. And that's not necessarily the way we recommend it be used. We tend to, for commercial applications where you expose that API to other people, you want to sort of restrict the type of API calls that can be made to more. But it's a very, very fast web server for getting data out of a database. In fact, so originally HIVEmind used a Python-based web server to get the data out of Postgres, and it wasn't bad. But we found that when we replaced it with PostgreST, we got much better performance. So there are plenty of things out there that hook up to Postgres to make the really, really nice interface for web server type API calls and things like that. Another tool I'll mention in passing that we also use is Swagger. You guys are probably familiar with this. Swagger allows you to basically document your API and actually interactively test it. So you can go to a Swagger web page and fill in a form on that web page, and basically the form will tell you what the parameters are to the API calls, and you can press a button and test the API call. So that's another thing that we recommend as a standard part of the stack now, besides PostgreST, when you're making an app. So you define your API, you have your PostgreST web server, which is serving up the API calls. You run Swagger on top of that, which will allow someone to see all the API calls that you have available just by going to a web page, and they can even test the API calls and see how they perform. So essentially, it's like a self-documenting interface for your API calls.
Fantastic. Yes, and although I have not had the pleasure of building a Swagger myself, I have received them. And boy, isn't that way better than other things to look into stuff. So let me just take this now. Boy, you're starting to talk about all these words. And do you have documentation and tutorials? Is that something that needs to be done? How can we, as you're, maybe moving towards a more complete rollout of this amazing and powerful new layer on Hive, how do you view the documentation and tutorials in a world of open source? Is that your job? Are you going to be writing the documentation?
So there's different documentation for different portions of things, right? So one thing, you have the documentation for HAF itself, which is to tell somebody how to build a set of API calls on top of HAF, right? So there is documentation for that. It's scattered among several files. That's probably the biggest problem with it right now, but they are linked at least, so you can go from one to the other. And so there is documentation for how to create a HAF app. But of course, like all documentation, I'm sure it can be improved. Now, as far as the APIs themselves, there's fewer people will be building HAF apps compared to be using the API calls, I think, in practice. There's probably more front-end guys than there are back-end guys typically. But for the front-end guys, the Swagger is really where we see the documentation being primarily done. So if you go to like api.hive.blog right now, if you actually just go, let's see. If you go straight to api.hive.blog and type it into your web browser, you'll see the Swagger. So this is basically documenting all the API calls for the stack, for all the HAF apps that are on our server. And you see if you go to the right top corner, you'll see a drop down. It says select a definition. So right now it starts out on HAF BlockExplorer. So it's showing all the API calls that are available in the HAF BlockExplorer. And you can do the similar thing for BalanceTracker, Reputation Tracker, or HAfAH. And as you add new, so that's one thing you'll see from this is actually we already support the BlockExplorer API on our server. It's not a part of the standard stack yet, so not every server will have that one. But this will basically be the interface for every API server, that you'll be able to just go to their main page or some other page where they want to put their Swagger docs, and then you can just walk through and see what APIs they support on their server, and see what the calls are.
Amazing. Yes, and I'm there. I'm looking. We're showing. Fantastic. Okay, and so that'll be the next podcast. We'll go through a call by call. Okay, so back to the list here. Fantastic. So, would you say then that a lot of the documentation work, at least at a foundational level, has already been done by your team?
Yeah. Because we're about to do a release, so it's a good idea to have the documentation there when you do your release. So we're releasing new version, and we've updated all the docs for all the changes and things that have been made.
Fantastic. And then tutorials. How important do you view tutorials? We talk a lot about Hive as a place where people could come and and play around. And I remember years ago, that's how we started, by playing. And do you think that this sort of documentation will allow people to play more? And how do you view, just generally, philosophically, how do you view the role of tutorials in
Um,
that?
Uh, Generally, I would say tutorials are quite useful. Although I think things are going to be changing a little bit, to be honest. So, I mean, typically, my first application I made, which had nothing to do with Hive, yeah, we of course made a full reference manual, but we wrote a lot of tutorials because people often don't want to read reference manuals. Uh, so that was you could say from that point of view, I view tutorials as quite important. But then I say things are changing, and the reason things are changing is because of AI. um, the way I get information now has changed a lot. I would actually be the kind of guy who would actually like to go read a whole reference manual, just sort of get a feel for everything that's possible. Tutorials won't always tell you everything that's possible. So, a little bit is your approach and what you're trying to do. If you're just trying to mess around with something, a tutorial's fine. But on the other hand, if you're going to go deep dive, you would dive into the reference manual, right? But that gets harder and harder to do nowadays because there's just so much information, and you don't want to take the time to learn everything about tools. But the AI stuff has really changed the way you code now. So nowadays, if you don't have to go study an API and learn all of it to actually go program that API nowadays, you can literally just describe what you want to do, point an AI at the API, and the AI can sort of help you write the code. It's kind of crazy, honestly.
Okay,
But
I
I,
gotta
I think
stop
that
you.
is the future.
I gotta stop you because we are those guys, especially GM. We read manuals, but more and more, we are reading with a friend. A friend is helping us read these documents. So just don't get off the rails here, but take 2 minutes and unpack AI. And a lot of people, I think, normies that don't know, they think API is going to replace competent devs. And I would say, well, then why haven't they already? But okay, so just unpack that for us. We'll do more on another podcast, but I can't resist it.
So, I mean, yeah, I'll give you an example of this. So, uh, GitLab, which is where we store the repository, where we store all their code, right? That's where we make changes to code. It gets put in GitLab and stored there. And so GitHub, of course, has its own API for doing things. So all the things you can do as a user, there's also API calls that do the same kind of things. But who wants to spend the time to learn the API for GitLab? But like, there's some things I want to do in GitLab. When I do a release, I have to tag a bunch of things with a certain version number, and I have to move things around. And there's a bunch of steps. It's actually quite a lot, probably about 40 or 50 things I have to do in GitLab to tag all the different versions of different pieces with the same number. And then I have to get the submodules to match up, which is basically how the links between the two repos. So this application depends on this other application. And all these things need to be tied together. It's about 50 or 60 steps, and it's very error prone. You can easily type something wrong, make a mistake, right? So I wanted to write a script to automate all that so that I could just say, here's the new version. Go tag everything that's in develop with this tag and hook them all up and fix up all the submodules, which basically requires multiple commits, everything. And so I wanted to write a script to do this, but I'm like, oh God, I need to learn how to use the API for GitLab and all this kind of stuff. And instead, I used AI. I just said, I told it basically what I wanted to do, and spent a couple hours with a friend talking to the API, telling it how to write the code. And, it basically wrote the code, and then we just had to like test it and fix the mistakes that the AI doesn't really make when they're doing stuff. But super fast. I mean, and now I save a huge amount of time when I do a release.
I love it. Okay, so yeah, that's a third podcast, but that's brilliant because exactly, it's making us better. Okay, so let's go ahead then, and the last thing on my list here is, what do you think still needs to be done?
So you mean in terms of HAF or just Hive, or that's a big question.
I'll let you go first, and then I'll follow up if anything you
Okay.
missed anything.
So in HAF, HAF is, with this release, I think it's pretty complete in terms of basic, all the things I wanted to do in HAF, they're kind of there really now. So mostly the stuff we're going to do next is building applications on top of HAF. There's still tons of work there. So one of the main things HAF was actually designed for was to be for developing second layer smart contracts. So that's one of the big next apps we want to do is create a second layer smart contract app. And we've we've been designing it conceptually for quite a while, but we haven't been writing code. Because the code we've been writing essentially been HAF, because HAF is like the base layer of that code. So that's one thing. Another app that's HAF app that's very much on my mind is something called LiteAccounts. And LiteAccounts is a way that you can do signing second layer, supporting and signing second layer transactions and second layer accounts. So you can create an account that's not necessarily a Hive account, but Hive will be able to attach keys to it and be able to check for second layer signatures on this second layer app. So it's a way to sort of extend beyond the first layer to second layer transactions. And that app can then be used by lots of different apps. Basically anybody who wants to build a smart layer smart layer system app will be able to build on top of that LiteAccounts system, for instance. So those are two of the apps that I'm really interested in for HAF.
Great. Okay, so those are, and it sounds like those are your priorities. Do you see any space for things you just don't have time for?
There's tons. I mean, yeah. I mean, there's so many things that can be built on top of Hive, on the top of HAF too. We certainly don't have time to do them all. So, if you want a wish list of things I would like to see, I had to come up with it offline. I can't pull it off the top of my head, but I'm
no problem. No, that you said it. The space is open to do infinite things, and I really like that. So just following on. This has been Deep Web3 Secrets.